Yeah, we shall be looking at uh, physical and physical quantities and their unit. Um, we want to talk about how they are important in the study of physics, and as a, as a matter of fact, you cannot do you cannot do without physical quantities, because it is the beginning of physics and the fundamental aspects of it. So we know that physical quantities and units are very key, because it is, just like I said before, is the foundation. A physical quantity, a physical quantity is a property of an object, something we can measure with instruments, or even by using our senses. And you can see that for any accurate design to be done, a certain measurement has been taken. For example, a carpenter trying to design a door or window would make use of some measuring instrument like tape or meter rule. Now, some of the physical quantities that we have are length, mass, and more. And some of them, more is a physical quantity which measures the number of molecules in a substance. Luminosity is an energy measure, just like temperature. Luminosity measures the quantity of electromagnetic energy emitted by an object as light per unit time. And we also have electrical charge. Electrical charge is a physical quantity that can be positive or negative, only affecting polarity. It causes a force to act upon the matter when placed in an electric field. Mass is the property that tells us how much quantity of matter is contained in the object. And an object with a larger quantity of matter has a larger mass. Weight is the force that is exerted over an object's mass. And length, when we are talking about length, we mean the property that tells us how long an object is. It is related to area and volume. And time is property that is related to the flow of events and is always increased. Like mass, time is one of the properties that cannot be negative. Time is actually the ongoing sequence of events taking place, the past, present, and future, to a layman understanding. And the basic unit of time is second. There are also minutes, hours, days, weeks, months, and years. We can measure time using clocks. Temperature is the property that measures the quantity of heat in a substance or object, and the heat is related to the movement of the particles in the object. So physical quantities have two categories. We have the extensive quantities and the inextensive quantities. This classification is related to an object's mass. Um, Extensive quantities depend on an object's mass or size, while intensive quantities do not. Some of the examples of the extensive physical quantities, mass and electricity, are a key examples of extensive physical quantities because mass depends on the size of the object. If you, for example, if you have two weights, maybe they are made from steel, and maybe one is double the size of the other. The larger one will have double the mass. So it's a clear example. And another example concerns electrical charge. If the particles of an object have some electrical charge, their number tells us how much electrical charge the object has. So if the object increases its mass, that's increasing its number of particles, the electrical charge will be larger. Examples of intensive physical quantities. The intensive physical quantity are independent property, while extensive are dependent property. The intensive physical properties does not change in size, but the extensive physical properties changes in size. And the intensive physical properties cannot be computed, but the extensive physical properties can be computed. So, examples of extensive physical properties are length, mass, weight, and volume, while examples of intensive physical properties are melting point, density, freezing point, color or other, you know, all of that. So it is explained already from the, just as I said before, intensive physical properties do not depend on the object's mass or size. Simple examples of these are time and temperature. So this are the basic quantities that we have, but some of the quantities are derived quantities. The derived quantities are calculated by two or more measurements to include volume, density, area. For example, area of a rectangular surface can be calculated in length by its width, and volume of a rectangular body can be calculated by the product of length, width, and height. So derived quantities are always expressed in some type of units. Many derived quantities cannot be measured directly, and some are calculated in physical or science. Examples of derived quantities are area and volume. So, in summary, physical quantities are important because they allow us to describe an object. Objects have a certain length, and a certain amount of atoms. The units are the values or reference we use to measure the properties of objects. Imagine measuring the weight of two rocks. You can tell by holding them in your hands that one is heavier than the other. But to determine their precise weight, you need to compare them against a standard value or unit. In that case, maybe the kilogram. So the seven elemental physical properties are mass, time, temperature, mole, length, luminosity, and electrical charge. Some derived physical quantities are velocity, heat, density, pressure, and momentum. Extensive physical quantities depend on the amount of substance or the size of the object. A vector quantity is a physical quantity with a value and a direction. An example of this is velocity. You need the velocity value and its direction to know what is happening. So physical quantities can be extensive or inextensive. They are extensive if they depend on the mass or size of the object, and in, and intensive if they do not.